Okay, so good evening, everyone. We are going to be, good evening, Favor. Today we want to look at NumPy arrays. Like I said the last time, I'll be sharing my screen now. Okay, please, can you confirm you can see my screen?
Yes, I think it just came up now.
Okay, so that's great. So NumPy is a very important aspect when you are dealing with or when you are doing data science, machine learning, and the rest. And simply, NumPy means numerical Python. So it's a library for performing scientific computation in Python. Ordinarily in Python, to do some sort of things you may need, especially numerical computations, you may need to go through a lot of for loops. So NumPy helps to reduce those for loops by doing what we call vectorization. So instead of explicit for loops, we can vectorize what we have, and that makes it easy. That makes it faster rather. So the main point about NumPy is its speed. So NumPy is very fast. And then apart from vectorization, it's because the code is executed in C. So because it's executed in C, it now makes it very easy for it to be translated to a machine code. So whatsoever computation you're asking it to do can be done easily. Secondly, it's easy to use. So it's just like Python. So it's also easy to use. And then it is open source. So a lot of people are actually working on it. Now, if you are using Python for the first time, in order to make use of it, you have to install Python. So depending on what type of what should I call it now? What's the word? I don't know the word. I have forgotten the word. So we install Python. So if you're on Colab, well, I think that Colab already has it. But if you are doing it for the first time, or maybe your personal computer, you may need to install Python. You may need to install NumPy rather by doing pip install NumPy. So when you do pip install NumPy, it actually installs everything that is needed. So I've been using NumPy. I already have it installed. So it says requirements already satisfied. Now, for us to start using NumPy, you can import NumPy by saying import NumPy, and then we use. So it's like a library that we use. So there's what we call aliases. Usually you don't see people using NumPy explicitly. So we use a shortened form of it to say import NumPy as NP. So whenever we want to use the library NumPy, we would instead use NP, and then we run the code. So since we also said that NumPy is fast, we want to test its speed. That's why we are using this import time to see the speed at which operations are being done. So import time, I would also import time. You don't need to pip install time or anything. Okay, so in this first one, we have the stats. And here we have time.time. Okay, let me just code it so that in case you are coding, you might also follow. So we want to look at the time for carrying out a sum operation when you are doing it with an explicit for loop, and when you are doing it with NumPy. So start will say it's equal to time.time. So it registers the time for which we start. And let's say that we are doing a sum operation and we are adding, we say np.sum. So this np.sum, remember I said that when we use, say, import numpy as np, what happens is that instead of using numpy, we use np. So I say np.sum, and maybe I'm trying to add a large sum. So I can say np.arrange. We are still going to look at what np.arrange means. But what it simply does is that if I put, maybe I say 200,000, so it picks number from 0 to 100, 200,000 minus 1, and sums up all the number. So, and then we are now going to get the end time. So end time is equal to time.time. So perhaps we can also print the sum. We can print A, and then let's say the sum is A. So I'm using the F string method. And then we can find the time taken for this function or this thing to be executed. And I'll say print the time taken. The time taken is, so we'll do end time minus start time. So when we run this, so we see the value of this sum when it adds up all the value, it's a very big number. And then the time taken is 0.01 seconds. So let's do it using an explicit for loop. So this first one is using numpy to sum. So if we are using explicit for loops to do this, what will be the time taken? So again, let's say start time. Let me copy this from here. Start is this. And then let's say our sum A. So when we want to sum this, we have to initialize and say total probably is equal to 0. And then we are summing for I in range 200,000. So we are doing exactly the same thing, but the difference now is that we are sort of using a for loop. So what we are trying to do is to be adding to this total to get the sum. So I'm going to say total plus equal to I, right? So I'm adding continuously to the total. So at the end, I can now say print the sum is total. And then I have an F here. I like the F string method. Then I want to look at the end time. At what time did it end? Just like previously. And then I'll copy this line as well. Okay. Yeah, so when I run this, so we see the difference is very, very large. This is about 0, it's not even up to like a fraction, a very big fraction, 0.01, while this one is 0.1. So we can see the time that it took for this sum operation to be carried out. And you know, sometimes or most times when you deal with big applications, you have a lot of things to do and a lot of computations to make. So that's where NumPy comes in handy, as it helps to reduce the computational time for carrying out something. So someone has a question. Anybody with a question? Nobody. Okay. So there are some important points we need to know as we go further in our knowledge of Python. The first is the shape of an array. So when we talk about NumPy, we mostly we use arrays to store our values. Now, all of these things, for example, here where I did np.array, so it's actually an array. Does someone want to ask a question? Okay.
I'm in a Zoom meeting.
Okay, so we would look at the shape of an array, the number of dimensions. So I think we have to really pay attention because these things really accumulate, especially dimension of an array. How is it important? The size, the data type, and the reshape technique. So first of all, when I want to make an array in Python or in Numpy, what I need to do is to call the np.array function. So I'll say x is equal to np.array. Okay, let's do it this way. So there are different ways to form an array. We can form an array from a list. We can form an array from a tuple. We talked about tuple. Is it tuple or tuple? We talked about tuples and list the other time. So if I have a list, say my list is x equal to, say my list is 1, 2, and 3. And I want to change this list into an array. So let's say T is equal to change a list to an array, just write it as np.array. What's happening? np.array, and then you write np.array and put this brackets, this round brackets. Then you call the list you have here, which is x. Then if I say print t, so this is what t is. It's now this value. I'm coming. Okay, yeah. So it's now this value. So this is now what we have. Okay, so having this, we can actually check the shape. What is the shape? Which is very important. The shape, the dimension, the size, and the data type. Okay, sorry, just a minute. I think I need to. Okay, so if we write only t, we would have array the value, right, that we entered. Then if we write print t, we would have only the value. So if I say print t, okay, let me leave this as x as t. And then I run this. Okay, I made a mistake at the beginning. I was calling x. So yeah. So when we create an array, like I said, we can create an array with a list, and then we call np.array the name of the list, which is t here. We can also create an array with a tuple. So let's say y is equal to 1, 2, 5. We can now say z, which is our array. We'll say np.array y, and then we say z. So when we run this, we also have this array. So we can create an array from a list. We can create an array from a tuple. Now, coming to these important points, how do we find the shape of an array? So let's take our array T. So to find the shape of an array is just simply T.shape without any without any brackets. And this gives us that is of shape 3, which you can look at it as 3, right? Now we can increase, okay, before I go there, let's do dimension. So we can say T.ending, that is the number of dimension in an array, is just 1. Now, what is the meaning of the number of dimension in an array? You can look at it as the number of axes in your array. How deep is an array? For example, you have, let's say a cube. Now, a cube, if I have a cube like a carton, right? We say it is 3-dimensional because it has height, depth, and width. Now, if I take just a slice of it, then it's 2-dimensional because I have just the length and the breadth. I don't know if we understand that explanation. So the ending gives the number of axes in an array, right? Okay. So next, we then have the size of an array. So the size of an array is simply just the number of elements in an array. So if I do t.size, and then I run this, so it's 3. And in this, our T, we have only 3 elements. So let me come back here and increase the dimension. So I can increase this. And then, so to increase, you can just add extra brackets, right? So I want to increase it and also increase the shape of my array, which is, let me say I'm putting 4, 5, 6, right? And then I say T is equal to this. I come back here and say T dot shape. What is T dot shape? So you see it's 2, 3. What this means is that 2 rows, the first value gives the number of rows, while the second value gives the number of columns. I forgot to increase the okay, so the first value gives the number of rows, while the second one gives the number of columns. A good way to look at this when you are writing it so that you not be confused is to put each of the list on separate lines so that you can be able to see the dimension properly. So this is your first row, this is your second row, right? And then these are your columns like this. So the first value in the shape gives the number of rows, and the second value gives the number of columns. So now, if I do T dot ending, you see it's now 2-dimensional, right? So you can look at this in the form of it has length and breadth, okay? Now, again, the size, remember I said that the size is the number of elements in the array. So if I count this, this is 1, 2, 3, 4, 5, 6. So if I do T dot size, it's going to give me 6, right? Okay, so next we have the data type. So the data type of an array is very, very important. And to find the data type, we just do d.dtype. Yeah, so int. Now, what if, why we have int 64 is because all the values within our T is, within our X are all integers. But if I add, for example, a float value and I do t.dtype, now we see that it now overrides that because we have a value that is not an integer. It now says, okay, everything is float. Now, what if I have floats? And then what if I have integer and I want to convert it to float? So we can do that in the creation of the array by specifying the type, the data type of what we are looking for. So for example, I have say Z, again, I want to write it in the form of a list so that we'll understand it. Put it in another line. And let's say it is 2, 7, 8. 1, 4, 9. And 2, 1, 6. Right. So I have Z as this, and I want to convert it to an array. Let's say it is M is equal to mp.array Z. So M, and I run this. So this gives me this value. Now, if I want to specify the type, so if I do now m.dtype and run this code, what it tells me is that it's in 64. But what if I'm interested in float? And then I'll say the type equal to floats 64. And then I run this. Okay, so Oh, sorry, not here. Control X. I'm supposed to put it here, the type equal to float 64, and then run this. Then when I do m.dtype, we see that the type is float 64, right? If I want to change it to complex, again, to be a complex value, I'll come here and say the type equal to complex. And when I run this, you see, we now have imaginary number, the real and the imaginary part for those that did that. And then we then have the type is equal to complex 1 to 8. Okay, so that's good. Let me go back to what we have. Shape, dimension, size, data type. Okay, reshape. Now, a very important function that can come to handy is the reshape operation. So what the reshape operation does is that it changes the shape of your array. But you have to note that the shape of the array, that is the size of the array, remains the same. So if I'm reshaping, I'll ensure that the size of the new array I'm reshaping to is the same. Okay, so for this one, let's increase the value and make it to be like this. Because 3 by 3, it's 9. So the shape of this is 9, and there's no way. Okay, we can reshape to 1 by 9. Okay, let's leave it like this. I want us to remove this complex. Okay, so this is M. And let's check the size of M. So the size of M, if I do M.size is 9. If I do M.shape is 3 by 3. Now I want to reshape to something that will still give me 9. And in that case, we are thinking about the product. That means what times what will give you 9. So I can do 1 times 9. 1 times 9 will give me 9. So I can say maybe K is equal to M.reshape. Then I'll now specify the new shape I want. I want it to be a 1 by 9 matrix array. So it can be 1 by 9, it can be 9 by 1. And then I'll say K. So what do we see here? We then have the array flattened out. So if I do K.shape now, K.shape will then be what? 1 by 9. So, but if I try to reshape this thing to something else, let me say 1 by 10. Now let's see what it will give to us. Here it says cannot reshape array of size 9 into shape 110. So what it does is that it says 1 times 10 is 10, and it is not equal to 9. So you have to ensure that when you are reshaping, you have the exact size of the matrix that you started, the exact size of the array that you started with. So here we can say 9 by 1 and run this. So again, when we do K.shape, it's 9 by 1. Yeah, so I hope that is understood. Let's do a little bit more and add maybe one more, say 5, 8, 4. So in this case, we have size 612 and of shape 4 by 3. We have several ways of reshaping this. We can do that. We want shape 2 by 6, and then when we run this, we have something of this nature, and we do K.shape is 2 by 6. So reshape is very, very important. So next we'll go to, I don't know if this is the right capture, special arrays, but they are not special in really, but we'll be looking at them. So we'll look at np.arrange. What does np.arrange do? So np.arrange looks at, it takes a value, the start, the stop, and the step. So it works like the normal range we know in what we have been doing. If I say for I in range, I think we looked at it some time ago, 2, 10, and I want a step size of 2, then I say print I. So what this does is that it starts at 2 and stops at 10 minus 1. So it doesn't get up to the last value. Then the step now says, okay, step of 2. So np.arrange works exactly the same way. So if, for example, I have an array, or I want to create an array, and I say np.arrange, now I can actually, okay, let's take it easy. I say start at 0, stop at 20, give me a step of 1. Okay, and I say y. Now, you see, it starts at 0, stops at 20 minus 1, which is 19. A step of 1 just simply means 0, 1, 2, and all of that. Now, if I don't specify step of 1, by default, it takes a step of 1. And when I run this, I still have the same value. Again, if I don't specify the start, it takes this one as sort of start at 0, end at 20. So if I run this again, it gives me the same thing that we have. So if you want to specify one value, what it does is that it takes the default as the start as 1, and then default the step size will be 1 as well. So again, let's say we have z equal to np.arrange, start at 4, stop at 15, step of 3. And then we ask it to print z. Okay, so it prints z as this, right? So again, I'm just discovering this actually. So if we use the print operation, it removes the array. It doesn't show the array, it just shows the value that looks like a list, but it's actually an array. So if I say z and then I run this, so it's going to give us an array of 4, starting at 4, ending at 14 minus 1, and a step of 3. Okay, so the next we have is the np.zeros. So sometimes you might be interested in getting only zeros. So what we do is that we have an operation called np. Is it an operation now? np.zeros, and then we specify the shape of the matrix of the numpy that we want, the numpy array we want. I don't know what I'm saying. Matrix. So 2,6. So let's say we want an array of zeros with shape 2,6. That is 2 rows and 6 columns. So when we run this, we find that we have this number of rows, 1, 2 rows and 6 columns. Now, maybe we want to do some other operation. We can actually add. So maybe we say we want to add 5 across it. So what it does is that it adds 5 to each element of the values that we have. Another important thing we can know is the np.ones. So what np.ones does is that it works just like np.zeros. In this case, it gives us a numpy array of just 1. So let's say we want 10,5, and then we run this, we have that value. Okay, so do we have any questions so far? Any question? We have few. Okay. So that's that for np.ones. So just like we did here, let's say we want to add, or we want to multiply, in this case, multiply by 10. So what happens is that it multiplies each of the elements in the matrix, in the numpy array, by 10 as well, right? Okay, so after np.ones, np.zeros, so another way to write np.ones is to specify the shape like this, as it is here, shape equal to 3 rows, 4 columns, and it will give you the same thing. So if you don't specify the shape, you have to make sure that you write two, what's this thing called? 2 brackets like this. For example, if I do np.zeros and I put only 1 of this set of bracket. Now what you see says cannot interpret 3 as a data type. So it's very common for people to write it like this. Make sure that the number of what's this thing called? The number of brackets are 2. Else specify it like this, shape equal to this. The same thing, okay? Then we have mp.i. So what mp.i does is that it gives you the identity. Is it the identity? Yeah, it gives you, what's this type of matrix called now? Yeah, the identity. It gives you the identity. Yes. So if I say mp.i2, you don't need to specify the number of columns. It's always a square matrix, right? So when you say 2, it gives you 2 rows and 2 columns, right? So if I say, now what an identity matrix is that on the diagonal, the values are 1, right? So for an identity matrix on the diagonal, the values are 1. So again, if I say mp.i3, what happens is that on the diagonal, the values are 1s, and in other parts, I hope we know what diagonal is. Diagonal means just something like you are taking the middle part, starting from the top left down to the bottom right. You are taking, like the way you do, what game is this? I've forgotten. You just take the middle part. So every other thing off diagonal will be zeros. Now, if I want to change this behavior, just like we've been doing, maybe I want something different to be on this diagonal, I can say times 14. So what happens is that since all these other ones are 0, anything multiplied by 0 remains 0. And on the diagonal, you have 14. So lastly, we'll look at mp.full. Now, what mp.full does is that you give it the matrix or the shape of the array and tell it what you want the array to contain. So in this one, we are telling it that, okay, we want only 9s. We can say we want the array to contain only 3s. So if I say mp.full 3, 2, so it creates a sort of matrix of 3 rows and 2 columns. Am I still there? Can you hear me? It's like my internet. Okay,
Yeah,
okay.
it's clear. It's
Okay.
breaking, but then it's fine.
Yeah. Okay, sorry, my Wi-Fi just went off. I'm using my phone network, so I would have to stop very soon.
All right, that's
Okay. Sorry. So mp.full, you take the shape and then specify what number you want to fill up the matrix. I think that's all I have for today. This is just like, should I say, is it tidbits they call it? There is still a lot on Numpy. So do we have any question? Boluwatidara, I think this is the first time I'm seeing you. Do you have any question?
Good evening. Sorry, I joined late. I got the information late, so.
Okay. Okay. Sorry about that. I think you're in the data science and AI group, right? The group for the Yandi Tech. Okay, so I'm sorry, I just realized that I should have told you people about it and I sent it in late, but we have a recording which will be available. So we usually have meetings every Fridays by 8 p.m. The group is Data Science Kaduna, mostly comprised of students from Kaduna. Yeah. So I just wanted to integrate it a little bit with the new group I created. So you're welcome.
Thank you very much.
Yeah. Okay. So I hope you found this, even though you don't understand, maybe you caught 1 or 2 things I'll share the recording on the group and even the past things we've been doing on the group as well, so that you can be able to go through it. And if you have any question, you can ask. I believe that we will be able to answer.
Yes, thank you very much. Please, what's your name on the group so that I can reach out to you easily?
My name on the group. So it's Ify, IFY.
Oh, okay. It's Ife. Oh, I know Ife.
Okay. Yeah, thank you. Okay, I'll be ending the call right now. Thanks to everyone that joined, and do have an amazing weekend. Vote wisely.
Bye.
Okay, bye then.
All right. Thank you so much for your time.
Yeah, you too. Bye.